files, knowing the software resources we currently have and what workflows are used at that moment. Okay. If you have doubts or questions at the end of the talk, we will be answering them in a forum space. So currently, I won't hide it from you. There are quite a few software options for guided surgery, and each one has its pros and cons, right? We are talking about the payments for export licenses, updates, memberships, and even the size of the program. There are programs that can weigh up to 80 gigabytes, which is quite a lot for software. So depending on the situation, to be able to select a program, I will always invite you to look at their capabilities, right? Programs can be open like a Blender for dental from Blue Sky and closed that is parametric like Exoplan or Dental Wings or RealGate, right? They go hand in hand in the step-by-step process. We must also take into account that guided surgery also has different levels of complexity, right? So we will touch on that a little later. So this is a slide of digital workflows, the last presentation we have in the introductory talk on digital dentistry. For what purpose create something called a digital patient? In some concepts, some academies also call them a virtual patient. Now, both are the same concept, the same purpose. To have all the two-dimensional and three-dimensional information of my patient in my software. Here I am showing you a diagram of what guided surgery is, but there are also other workflows that we have covered in other talks, such as the design of digitally programmed splints or bisables, the design of removable complete dentures and implant-supported ones, and in the same way, what fixed prosthetics are, and all its variants, crown, veneer, inlay, fixed 3-unit, and prosthesis in the frame. Ready? So let's start with the workflow in guided surgery. What should we consider to start a workflow to place an implant? First, there are 3 levels of complexity in guided surgery. There are the guides, or let's say the design of guides for dental fixation. There are guide designs that have dental fixation and also bone fixation. We will also find double interface guides. So what you are seeing on the screen is a dental fixation guide where we only use teeth but we are not using any fixation pin. Here we are referring to what are dental fixation or support guides. We will have a second level, which I personally find a bit more complex because we will have to use both dental fixation guides and bone fixation guides. So it will be a brief introduction about what Blue Sky is. So Blue Sky 1 works through panels, which are the ones here. You will select the one you need and automatically have it here. Secondly, we can maximize the screens. Although there is a triangle in the corners, it allows me to increase or decrease their size. Secondly, the 4 radiographic views are, let's say, interconnected. An example, if I have my implant from the coronal view and I position it, see that in the 360 view, in the tomographic panoramic, in the 3D, and even in this view, here is the image, look at it. All the screens are interconnected. So these images help me to see and to navigate in the software. And we are going to start with the first step, which is segmentation. So how am I going to start? What you are going to do is click on the top right where it says Advanced. Then they do the exercise again and enter master models. What is the purpose of that? To find this menu called segmentation. This menu automatically will allow you to segment the maxilla or mandible. What does it segment? Teeth, nerve cortices, the upper jaw, and the lower jaw. In some cases, perhaps also to segment airways. How am I going to segment? You, depending on the jaw you are going to work on. In this case, both jaws, right? So I will leave both options activated and select the option that says Start Segmentation. The software will automatically start the process and show me this. Done. And below these conditions, for example, these are the scans. I always copy the root directory. It's the easiest. So what am I going to do? Once I segment here, I have and I have the tomography. These are the two files we need, or the conversion of the tomography. We need to start the planning process. So it is very different to have these 2D images compared to having the actual state of the patient's bone, the real anatomy, and besides, we need to add the scan. With the scan, what will we have or what information will we obtain? The length of soft tissue or the thickness of the soft tissue in certain areas. I am going to import the STL files. In this case, well, the Blue Sky Network system, I don't like it. I work more with this type of window, and what I'm going to do is import this separately, the scans. In this case, I'm going with the jaw. I am going to open it. I indicate depending on the jaw. In this case, it is the lower one, and it automatically aligns all the files or the STL on the jaw. Look how it turns out. He already used force, but it's due to the user's lack of knowledge about the tool. What are we going to do? I'm going to hide everything that is the upper jaw. And here, done. I will also hide my tomography. Under these conditions, I can now, let's say, start the planning process, Washa, because I already have all the two-dimensional and three-dimensional anatomical information integrated. And under these conditions, I can now place or plan an implant. There are processes, there are moments where this alignment or this match fails. But why does it fail? One, a bad tomography that is very short. What does very short mean? The window, well, there was a small space left to place 3 implants, meaning it's a very small space for a very large rehabilitation area. Secondly, the fundamental scanner, right? I mean, everything that ends in runway and all its variants, not to criticize, are photography scanners. So what they design are scanners that will leave this type of lesions on the mesh, right? Sometimes you don't see it when you scan. You say, well, I took the whole image. It looks very nice on the computer and fine, right? But at the moment of designing, look at what we find, right? A removable one here will never fit. See? So it is here at the design level where we understand how well or how poorly a Chinese scanner might suit you. How are we going to start our planning process? So from master in models, I will jump to advanced. I will place 2 implants in the 3rd quadrant and 2 implants in the 4th quadrant. Let's go to panels. Let's import or select the tab that says implant list, and a library or a menu of libraries will appear here. You will find that the most important thing in guided surgery, well, first is a periodontist or surgeon to place them. The second is to know your surgical set. Why do I mention this to you? The surgical set allows you to identify the process or drilling protocol for each of the implants or their lengths. So in this case, I will work with the commercial brand Adin. So mark your surgical set, and now I say here in implants, add implant. Here I will have the brand, all its models, and the models have different sub-models, which are the implants with their different lengths, platforms, and thread types. So in that case, I am going to work with the Turit OS. What is the difference between an OS and an S? The surface. The surface in the OS is treated, and in the S, it is not treated. In that case, I will go with a base implant, as the literature calls it, of 11.5 by 4.2. You must select either the upper jaw or the lower jaw. In this case, it's the mandible. Look how I go and click accept. It seems like nothing happened, but the implant is on the cursor. The only thing I have to do here is click the left button and it automatically positions itself. Now here I must keep in mind that the implants for us from the digital side, we find it convenient or important to know their three main components in planning. Ready? Because rehabilitation is another story. The implant itself, there is the abutment and we have the ring or the surgical guide. This guide is what you will configure according to the commercial brand. I will first do the planning and then proceed with the guide configuration so you can see how the process is and keep it in mind. That is the reason why the rings of, for example, of mine are not useful for placing implants from the inside due to the external diameter, because this does, the configuration comes from here. So it's not just about saying I'm going to make the guide and that's it, but about knowing the entire drilling protocol, how the implants work, what the sequence is. Even in the planning, what I recommend is that the easy process. Place the implant in the work area. I minimize and now go to the 360 view. Why? The 360 view allows me to rotate the implant or see all the structures around the implant. Look at it this way. So now I have a better criterion for positioning it and even saying, I know I'm hitting the mental nerve here, saying, hey, that 11.5 implant doesn't work for me. I have to reduce the length. So to start over, no, says I just mark here, no replace. If I'm on that implant, I'm going to change the length, but I'm going to keep the platform. I'll stay with 1 of 10.
It is reduced. It doesn't work for me.
I'm going now to 1 of 8. That works better for me. Ready? So see, it's very easy to even evaluate the process. Sometimes in the 2D tomography, one says, here there's a space of 3 millimeters, here 5, a short implant fits there. No, enter the software, visualize the tomography, look closely at the bone, and position the implant. Now look at what it's showing me. 1, the surface is, and it is to be able to make this translucent, and exactly how I have to move the implant inside the bone. So I start to push it, I can rotate it. If I hit the nerve, nothing will happen here. What it will give me is an emergency signal saying, hey, that way doesn't work for me. Position it in another region. I can bring it a little closer and I could leave it there. The goal here is for you to know what the management tools are, at least what the axes of rotation are. Now, regarding the part of placing the implant properly, well, that's when we enter a reevaluation process. But the essential thing is to know the digital workflow. Ready? So once the implant is positioned, I'll make it simple. Right-click, duplicate, and I move the implant back. So I already have the same implant in the same, oh darn. I made a mistake, Control Z, and I automatically go back to where I was, right? So that's what's cool about these kinds of tools, being able to evaluate all those details. And I might go back to the implants menu, select ID. I already know that it's an implant 0 that I need to look at. I return to the 360 view, and here what I'm going to do is reposition it. You might ask, well, how do you know at what depth to leave it? So I look at the cortical bone and count from there down 1.5 to 2 millimeters. Always submerge the implant that length so that the resorption process doesn't cause any thread exposure or the implant plateau itself. And now, if I suddenly see that I am hitting the nerve, I can rotate it forward, but the rotations, be careful. Always look for the profile of the crestal area. so that the rotation of the implant is done on this axis. Ready? And we don't have any problem with loss of plateau height. So notice that we already have 2 implants in less than 5 minutes. The next one, right click, duplicate. I move it to one side and place it here. I reposition it. I can leave it straight. I can place it here in the area that is moderating. This is the cool thing about being able to have the scan and the sequential tomography. I mean, it makes it easier for me to see which are the best areas for these implants. I go back to the 0 implant. Here I can already use a longer implant. In this case, I can go with one that is 10x4.2. I can rotate it. If I see that it's colliding, I have to look from the 3D view to see if I can address the collision. So here I can change the plateau, okay? It's very wide. I can lower it from 10 to 375. How does this help me? By reducing the space, I can rotate it and even raise it a little more. I look here and I'm not hitting or touching the nerve cortex. Let's go with the next one. You might say, we've got the implant is to one side, but look at the scan. The scan sometimes shows you the anatomy, the ridge, but the bone always ends up being to one side, and it's not because it has a bad match. They are bone lesions where we see there is a loss of width, and that makes the implant have to have a somewhat noticeable divergence in those types of processes. Let's go with the next one, duplicate. And I take it back. Now, recommendations. When placing 2 implants together, ensure that the ring, the internal insertion path, does not collide with the internal insertion path of the adjacent implant. If it collides, it is advisable to make 2 guides, okay? To avoid, well, problems in the milling. In this case, since the tooth has an aggression towards the mesial, we have to work with 2 guides. For example, this internal width or this internal hole cannot be affected in its path by the adjacent tooth. Where the tooth interferes in this region, we will have problems when fitting the ring. So, pues, well, it's the truth. Pues it's a hassle, those kinds of problems. What do I prefer to do? In this situation, I place here or make 2 guides, one for the mesial implant and one for the distal implant. I already have my planning ready. I already have, well, all the information. So what am I going to do next? In this case, for DIN, the external diameter of the DIN drums is 6.5 and the height is 4. I do not recommend leaving that height at 4, leave it at 6. Keep one thing in mind. If the drum is as tall as the ring, when I do the Boolean, the soft tissue will remove part of the drum, and when the ring enters, the soft tissue will expel it because there is nothing to cover it. Yes, that is a very big problem. By leaving the drum longer, the ring is halfway. Right? I will have a better interface for the ring to settle, and I won't have problems with the soft tissue expelling the ring, which is frankly a problem that occurs when the bone loss is in width and the implant has to be submerged because you cannot level that interdental area. I mean, it is not justified, right? See, what needs to be done is to submerge it and know the drill system in order to use not the indicated drill but other drills from the same system to position it. But we will see that in the guided surgery course we will have in the month of October. Ready? So I made the modification to my drum. What I am going to do now is mark here where it says apply to all drums. And this function, it automatically sets the measurement for everyone. Look how it turns out. And there it would be. Well, everything absolutely configured. What should I do next? Export all this data and I will obtain this information. Once we complete the planning in Blue Sky, we go to the screen in Blue Sky. We will have this file, right? Which is the one I was showing you before the commercial break. It's the segmentation of the planning. Ready? This folder, which is my patient's folder, is the order, right? Suddenly, some users coming from other programs are used to first creating the maxilla order, importing the file. Well, this is the same, just in a slightly more rustic way, I would say. Up here, this is the folder of the file. So what I do is copy this address, Control C, and I go to Blender. Well, Blender opens from the user interface. Here are the modules, the user information, the equipment, everything related to Blender. Here, a button appears to execute and I reach that interface. Ready? Blender will show me by pressing the N key, the Blender for Dental Work menu. And here on the right-hand side, we will find the modules. Ready? The essential module is the models module because it allows me to both import and export files. And it is the central module itself, right? So I will start importing everything. The file is imported as STL. I paste the address up here, press enter, and I automatically reach the patient's folder, select the file, and import. It's like a sequence just to bring up the interface. Here, there is no order of whether this is the upper or lower jaw, right? It's completely free. This is what I import. It seems like it's a single model, but this is where the connection between the two programs comes in. As you saw, I did the planning in Blue Sky for free. The guide I will make here in Blender, where I must have the original software. Do not buy pirated software. Honestly, that's like having a window to all your private information on the computer, right? I mean, the crack has a very high price beyond other private information, okay? So what do I do here?
It's very simple. You are going to select here separate elements.
Here, I can separate objects. I will have my upper scan here, my lower scan, my maxilla, airways, the teeth. I combine them. I will have my mandible. I will have my 2 chin implants. I will have my 4 implants. I will have the 4 rings. I will also have, well, the teeth. I join them by pressing Control J to have a much faster handling, right? I mean, if the elements are loose, like central, lateral, canine, I mean, it's going to be a mess for the computer and it will become slower. So if you align them, handling will be much easier. Control J to join. And if you don't like using commands, well, it's simple. Here is the option to join objects. Separate and join. Done. So now I press Alt H. Yes, here are some small commands that I will be explaining to you. ASIC is PTP. Is used to hide, and Alt, I hold it down. The H key to view everything I hid. Ready? Now I'm going to hide all the elements and I will only keep this element. Look at the errors of a Chinese scanner. I mean, don't take it the wrong way. I'm not being sarcastic or saying this is the best. You have to buy it. No, I am showing you the consequences of the photography technique compared to the video technique. Ready? This is the mesh. In theory, this is the vestibular surface of the tooth. We all know that's not the case, and this happens because either it wasn't cleaned well or the light was removed. I mean, there are quite a few external factors that cause this to happen. Look here at the mesh of the folds. I mean, literally, we want the scan to align with the tomography and not generate any errors when I'm scanning with that type of quality. Do you understand the reflection I want to convey? It's not about using the economical option, right? But believe me, a scanner pays for itself. Nowadays, it pays for itself. So it's good to go with a highly recommended Panda, especially for implantology, because it scans metal beautifully. While the Medit obviously is a much higher range, even more recommended because it has an interface recognition algorithm. It's a topographic map that's cutting edge technology. Not even the other brands, which are also good, have that. Ready? Because the scanner is not the only problem. You also have to train in its use so that these types of errors don't happen to us. Look at the other mesh errors, right? I mean, this is a fault. This is what we see in the software, and this is what we see structurally within the software. And obviously, this will not generate any benefit for me in the design. I must fix it. And that must be done in all programs, regardless of the user working in. I go to the third tab, Model Cloud, and select Scope. By selecting it, I start to smooth. I want you to see this. This smoothing I'm using is called simplified smoothing. What does it mean? That smoothing with the smooth I have up here. If I use smooth, I deform the surface. Smoothing. Simplified smoothing reduces its distortion margin, maintains the surface, and smooths that surface without distorting it. So that's what I need to use because the software has it for that type of problem. So notice that just by knowing the difference between two brushes, I solved the problem of a Chinese scanner. I mean, I'm not saying to buy it, then buy Blender to fix the mesh problems. It could be, but no, it's not ideal. Well, I'm going to smooth here and smooth here. Okay. I evaluate the other sides. Well, at least where I'm going to go in. Yes, I mean, I smooth with the left click. No need to press any other command. Just left click and that's it. Now I'm going to finish my smoothing. What do I do? Well, I say exit here. Now, I am going to make the arc cut. This is very simple. What you are going to do is select the model, press T. Here it says cursor. Select it and place it here or here. The important thing is not to place it here, okay? You put it here. And now you are going to mark arc cut. This path will come up 1 node, 2 nodes. I can go through either one. There's no directory telling me it has to be this one. No. So pay attention to this. I select with a left click, press the G key, and move it to the side where I want to continue my cutting path. And I start with the E key. Left click, E, left click. With E, I extrude, left click, fix, E, left click. Now, when I reach that point, what I do is mark merge, I say trim. I wait a moment. Here it makes a division of two structures or two surfaces. Say I need in flashlight, and then I say clean. If this happens, because now it's because the scanner was for photography, right? This for the Blender designers in the chat. When this happens, it's because the scanner is for photography, and what you need to do is check here. Now remove color, ensure the normals haven't been damaged, meaning flip them, uncheck, and that's it. Tick. Now it's my turn to create my working model that is mounted on a base. In this case, it's a lower model, lower base. Look how it would turn out. If it's too short, edit, I move it further down. I already have my study model. And from that, Look at me here. Here I already had the model a bit advanced. I already made my blockout model, which is the model I will use to make the guide. In other words, the guide is not made on the original model, but on the blockout model, okay? Pay attention to this. It is very important and applies to all programs.
Now, here I already have my rings. Here in the background are my implants.
I do the same exercise. I will place my cursor here and here in the guide module of Blender for dental. It says tubular method. Blender allows us 3 types of mesh for guides: tubular, layer, and drawing, right? Drawing, cool to learn. A layer is when you want to loosen up a bit more. And tubular is when you want to do things your own way, right? So we're going to work with tubular. So what's the process? I select my model, place the cursor, and mark this option that says draw. This module will appear. Before starting the whole process, we need to know the thickness of that structure. So here in item, which is a menu that Blender has by default, it allows me to know. Look here, you can see 2.6, 2.7, 2.8. So we will always work with guide thicknesses of 3 millimeters and up. We will never work with a surgical guide at a layer thickness of 2 millimeters. Why? Because it becomes very soft, and during photopolymerization, being so thin, it will deform. That's where the 3D printing errors start. Ready? So let's always work with a layer thickness of 3 millimeters and we won't have any troubles. The consumption of material, well, is not something that affects us or any consideration, right? Now I return to my guide module. I already know what that thickness is. Beginning. Do you remember just now when we were doing the tracing? Left click, the same command. When I want to make a mesh in the shape of a tube, the command is to press E, extrude, left click, E, left click, and I do this, well, as I like, okay? So, ideal, when you always reach the drum area, touch the drum, important to create a single structure. Now, when you see an area like these adjacent ones, what I recommend is touch the tooth. If you leave it partial when you place it, this area being contractile will cause the guide to pivot. It happened to me once. So don't do it. I keep pressing nodes, right? Here I go for the torus. Now, if you noticed, on the buccal side, I send the line upper third or incisal third. On the lingual or palatal side, I will send the line that is at the middle level, right? Touching papillae. So it copies here and copies here on the line. And this is the strategy of, and it is printed. There we are showing you all this step by step. So look, I get to here, make a small turn, reach this point. Here I am getting closer, and well, here I made a mistake. Control C. And again, and here what we just did, merge the two ends, right? So here I already have, let's say, 80% of my guide done. What are we going to do next? I'm going to click here on Reorganize Mesh. The size of the boxer 0302 is great. It won't affect the render or anything, okay? Like you already have the mesh of my guide here, but I need to adjust it a little, okay? So what I'm going to do is a form or a benefits for having done it in tubes, which is this one. I can go directly into smooth and modify it even more than it is. While in the other methods of layer creation or drawing, it's a bit limited in this part, okay? So what I do is select the mesh, smooth, and smooth all the areas where I see that kind of faults. I need to make the mesh very homogeneous because booleans do generate errors. So I smooth out all these areas well. Ready. Now press T and all the block brushes appear. That's it. I'm going to use loop. For what? To increase the fill. Everything as this part directs. I leave the windows here in lingual. I keep smoothing down. So notice that the windows no longer have to be square, but they can be the same width of the incisal edge or maybe the occlusal edge, the present teeth, right? And their finish. And now the booleans start. What are booleans? I'm going to hide this model for a moment. Look. I hid the model as code you the lower area. It's not fitted, right? If you see these folds, this both in ExoCAD and in Blender are what cause the errors. What do I like? Well, honestly, to smooth them out right away and not pay the price later. Let's say correcting the measure already well damaged, which honestly are. But yeah, it's a troubleshooting. Ready? Now I'm going to select the guide. I say here, semantic vault. I say select elements for booleans, and with the dropper, which is here, I select the model. I say now trim, and look how it turns out. Ready? I already have my coupling intact. Now I have to start making that same coupling with the rings. Ready? Notice that the rings, whether they have bone or gum, will always end up deforming. Yeah, I laced the rings too short. Shit, believe me, solving that problem of the drama to one length and the ring surpassing, oh no, frankly, I prefer to redo the guide. Why? Because I will generate errors. I mean, just with the gum pushing the drum 0.1 millimeter, I already have an angulation. Yes, so, and at the bone tissue level, it's quite a lot. I mean, in this 1 millimeter is too much space or too much margin of distortion. Oh, something I did, let's say before doing that whole process was to configure the rings. We have to configure the rings both in the internal area, their path, and their external area, right? But as I was saying, we need to save material for the course in November. That's what am I going to do here? I'm going to do the following. I'm going to select the drum, check the option to select elements for Boolean, and with the dropper, I'm going to select this external shadow. Notice that I marked the external area. If it looks like this, I can immediately mark cut and nothing will happen. If the guide is being affected in this area, we can do the same exercise. Select the guide, select elements for Boolean, and with the dropper, the external shadow to cut that small area as long as the guide interferes in those spaces. Now, since I finished using it, I can hide it, okay? Let's now clear the insertion path for this drum. Look at this. Do you see why I prefer to make two guides here? That's what we do in the course. Here I am going to make just one, but quite a bit of the milling area is lost, which is affected in this, well, in this area. I wouldn't recommend it, okay? It's better to make two guides here instead of damaging the two embryos. So I select the drum element for Boolean, and with the dropper, see that it automatically cuts. Apply. I don't need it anymore. No, just kidding. I need to trim here. I select the element.
Here and cut.
Look how we're doing. Now it's time to clear the internal area. This is done in all programs, but in Blender, the configuration of the rings is done manually. What makes that easier for me is that if suddenly the journalist or the surgeon wants to change the implant, I have access. I make it easy to change the drum without so much fuss. So once the guide is finished, let's say I've already printed the guide and the surgeon told me no, I'm not going to use that implant, I'm going to use a shorter one. So what I do is change the implant in blue sky, export the drum, bring it here and just do the booleans on that drum, and that's it. I don't have to do everything again like in other programs. Since being so automated, they don't have access to that type of problem solving. I select the guide, select an element for Ubiano, and with the dropper, The shadow, internal when they are internal cuts. If the software takes a little longer, the important thing here is to have a good graphics card for that type of problems. Look at what I made the cut. I tell you to apply it at once. Now I need to cut out that area. So to cut this area, I must first select the drum adjacent to the one it belongs to, and with the dropper, the shadow. So ready. Same exercise here. I select that drum by selecting the dropper, and with the shadow we are cutting these. Let's go to the next block. I'm going to make the 2 cuts. Here we are going to do the same. I select the drum, select the element for Boolean and the external shadow. If this happens to you, don't worry. This is a cutting error. Yes, what you do is select with a click. Look at my mouse. 1 click here, 1. There I already have the shadow. I press the S key. I decrease its size and I solve the problem. But I must select the drum again to be able to apply the cut, and the action is reflected. If I don't do that exercise, it is not executed. Yes, let's go with the next drum. Let's go with this adjacent external shadow. Apply. I can already hide this as an order sequence. Now let's go with this one. Apply what I have left to do the internal cut, and the drums are ready. Then I select the guide. It is no longer a drum, and with the dropper, the internal shadow. How does it look like? The same exercise here. Select the guide. Select element for Booleano, and with the dropper, ready. We hit apply. So, once I make the external and internal cut both on the drum and on the guide, I consider the design of the guide finished. Ready? Yes, here it is. I leave them this way because if suddenly later I have to change the diameter of an implant, then I have the free possibility of making that change without any book. Yes, if I merge it, I merge the drums with the guide, then I'll be done. Subject as if it were a wizard software. Yes, if I have to make any changes, well, I would have to start over by making the cut on the model of both the drum and the guide. We are not going to have coupling problems. Yes, that is what I should always evaluate when I'm doing my planning, but it is already from the guide design part. So then I already cut down these 2 that are like the ones that are most affected. Well, here it helps us a lot. So how do we export this? I select the drums by pressing the Shift key. And finally the guide. I can do it here. I can do it here is to export the STL. Here guide, I do not check this box, which is selection only. It is only export the selected. I go to my folder. Here I have it, ready. This is what I would send to print. In that way, I can work 4 implants, 5, whatever you need. Thank you very much to all of you, and I will see you next time. Okay, see you later.